SCP Algebra 1. This is Chapter 2's SLI, worksheet number 2. So we want to solve this. Remember, you solve it just like you keep that just as you would as an equal sign. So we're going to add 4 to both sides. So we have greater than 9. So we want things that are bigger than 9. If the letter or the variable is on the left side and there's nothing with it, no negative signs or numbers, it's solved. So this is going to say, hey, we're going to go from 9 to infinity. Okay, so it's a soft bracket 9. This is your interval notation to infinity. Problem number 3, we're going to add 2 to both sides. So I get y is less than 0. Okay, so on a number line, you think you got a 0 here. It's going to go to negative infinity. So if you make your interval notation, read it left to right. It's a soft bracket on the 0 because we don't have the equal sign. For this next problem, what I would do first is I would actually flip the whole thing over, including the sign. Okay, that way you have the x on the right side. That way it points to which way you want to make your interval notation. 60 over 12 is 5. So that's pointing to, this is going to negative infinity, so it goes from negative infinity to 5, soft bracket. So notice I didn't draw the graph that time. So sometimes you don't always have to use the graph. For problem number 7, we're going to multiply both sides by 5 first. And so I get 3x is greater than 5 times 15, which is 75. Divide each side by 3. So x is greater than 25 because 75 over 3 is 25. So this is going to be going to infinity. So it's going to go from 25, soft bracket because I don't have an equal sign, to infinity. Number 9, let's clear the denominator just like we did when it was an equal sign. So I'm going to multiply everything by 3. So I get 2a plus 3 times 11 is 33 is greater than 9. Then let's go ahead and subtract this. Those cancel, so I get 2a is greater than negative, let's see, is that 24? Divide each side by 2. So a is bigger than negative 24 over 2 is negative 12. So this is going to go to infinity because that's what the arrow is pointing to. So soft bracket at negative 12 to infinity. Okay, we can distribute the half over, or we can multiply both sides by 2. But let's do the half because everything is even. So half of 2 is 1, so 1x, or just x, minus half of 6, which is 3. It's greater than 5. Add 3 to both sides. So x is greater than 8. Okay, so this is going to go to infinity because that's the way it's pointing. So it's going to go from 8, soft bracket, to infinity. And that's all done. Let's get rid of these. Okay, the optimum says define the variable, write in the inequality, and interval show reasonable values of the scenario. Draw the graph. Okay, and draw the graph is the last thing. So temperature between 65 and 75 is optimal. So 65 and 75. Okay, so I wrote the interval notation first because I could see that. So now I know that I have to be greater than and less and like that. Oops, actually I'm going to go. I flipped my signs the wrong way. I'm so sorry. So I'm going between these. And then my number line is going to go, I have a 75 here. I have a 65 here. I have an open dot, shade in between. Now, number 15, the amount of water in, the amount of water in a 20-gallon fish tank decreases when it is drained for cleaning. Okay, so X is going to be less than 20 gallons. On a number line, if you had a 20 here, you'd have an open dot going this way because you're draining it. And interval notation, I guess, would go from, it'd actually go to 0 because you're not going to go to negative infinity. Like you'd have 0 gallons. And I guess you could go hard bracket because when it's totally empty, it's nothing there. Okay, and I guess you could then add this if you want. Check with your teacher, see if they want that or not.